Hi, everybody. Really glad to be here. Hope you're all doing well. I'm here to talk about hybrid cloud access control in a self-service compute environment here at Comcast. I want to just real briefly mention that Comcast takes very seriously its commitment to our customers to protect their data. I'm part of the Comcast, what we call data experience, big data group. And big data in this case means not only public cloud, but also on-prem data. So we have a heterogeneous data set, which offers some challenges, and challenges are fun, right? Our vision is that data is treated as an enterprise asset. This is not a new idea, but it's an important one. And our mission is to power Comcast Enterprise through self-service platforms, data discovery and lineage, stewardship, governance, engineering services, all those important things that enable people to really use the data in important ways. And we know, as many do, that powerful business insights, the most powerful insights, come from models that integrate data that spans silos, insights for improving the customer experience as well as, business value. So what this means for the business, here are some examples. Basically, this is based on the tons of telemetry data that we capture from sensors in Comcast's network. We capture things like latency, traffic, signal to noise ratio, downstream and upstream error rates, and other things that I don't even know what they mean. But this enables us to do things that improve customer experience, like plan the network topology, to help if there's a region that has a ton of traffic, we might change the topology to support that. Minimizing truck rolls. Truck rolls are what we call it when the Comcast guy, cable guy comes, or cable female comes to your house. And in times of this COVID times, we really would like to minimize that even more. And if we can analyze the data ahead of time, we can perhaps make any adjustments or suggest adjustments that the user can make to minimize the need for people to come to their house. We can monitor, predict problems, and remedy them often before the user even knows, because of this data. And this involves both the telemetry data and integrating it with other kinds of data across the enterprise, and then optimizing network performance for a region or for a whole household. So, this is really important stuff, and it really helps the customers. And we're working to make this even more prevalent. So, what makes your life hard? This is a professional statement. If you want to talk about personally what makes your life hard, we can do that later. But what makes your life hard as a data professional? People usually say, I need to find the data. So if I'm going to be integrating data across silos, I need to find it. I know where it is in my silo, but and the way we do that is metadata search and discovery, which we do through Elasticsearch. Then once I find the data that might be of interest to me, I need to understand what it means. So what someone calls an account ID might not be the same account ID that you are used to calling an account ID. Billing IDs or back office account IDs, you need to know what it means in order to be able to join it to make sense, as opposed to Franken data, monster data that isn't really appropriately joined. We need to know who produced it. Did it come from a set-top box? Did it come from a third party? Who touched it while it was journeying through Comcast? If it came in through Kafka or Kinesis, and someone aggregated it, and then maybe somebody else enriched it with other data, and then it landed in a data lake. The user of the data in the data lake wants to know where the data came from, who added what piece. And you could see this as both the publisher looks at the data in the data lake and says, you know, this looks screwy. What's wrong with this? Who messed up my data? You could also say, you know, or they could say, wow, this is enriched really great. I want to thank that person, right? And also someone who's just using the data wants to know who to ask questions. You know, what did you enrich this with? Where'd that data come from? That kind of thing. So, and all that really is helpful when you're doing this integration. That's data governance and lineage, which we do in Apache Atlas. That's our metadata and lineage repository. And once you found data and understood it, you have to be able to access it. And we do that through Apache Ranger and its extension that's provided by Privacera. Once you have access to it, you need to be able to integrate it and analyze it across the enterprise. So finally, now we get to the good stuff, to be able to actually get our hands on the data. And we do that with self-service compute using Databricks. And Databricks is a really powerful tool for that. And finally, we find that we do really need ACID compliance for important operations. And we do that with Delta Lake. So I can talk about this in more detail as this talk goes on or in the question session. I'm an architect, so I have to have box and line diagrams. So this is a high-level view of our hybrid cloud solution. So in Comcast on our data centers, we have a Hadoop data lake that involves Hadoop Ranger and Apache Atlas working together. We are, as many companies are, kind of phasing that out, but not immediately. It takes, you know, takes a while. We have a Teradata enterprise data warehouse. Similarly, we are thinking to move that not necessarily to the cloud entirely, but maybe to another on-prem source like Object Store. We use MinIO, and basically that makes this Object Store look like S3. So when the Spark jobs that we write to use on S3 also can run on our on-prem data store, and that's a big plus, of course. And for that, we have a Ranger data service that helps with access control there. Up in the cloud, we use AWS, though Azure also has a big footprint in Comcast. In Databricks compute is kind of the center here. We use it to access Kinesis. Redshift is we're just starting with that. We use Delta Lake and S3 Object Store, and we have a Ranger plugin that the Databricks folks worked carefully with Privacera to create, so that our self-service Databricks environment can have all the init script and the configurations that it needs to run the access control that Privacera provides. We also use Presto, and for our federated query capability. It also has a Ranger plugin, and all the tags that are applied to metadata on which policies are built are housed in Apache Atlas, and Ranger and Atlas synced together, and that's how Ranger knows what policies to apply to what data. And in the question session, if you want to dig deeper into any of this, I'd be very happy to do it. So this is very exciting to me. We're just rolling this out, and it's so elegant. And I didn't create it, so I can say that. So Ranger and Atlas together provide a declarative policy-based access control, and as I said, Privacy extends Ranger, which originally only worked in Hadoop, to AWS through plugins and proxies. And one of the key ones that we use, of course, is Databricks on all three of these environments. And basically, what I like about this is we really have one Ranger to rule them all. And Atlas is his little buddy because he provides, or she provides, the tags that really power access control. So here's again a diagram. We have a portal that we build for our self-service applications, and the user tags the metadata with tags like this is PII, this is video domain, that kind of stuff. That goes into Atlas. The tags and the metadata associations are synced with Ranger. The policies based on that. So who gets to see PII? Who gets to see video domain data? Those are synced and cached in the Ranger plugins. And then when a user calls an application, whether it's a cloud application in Databricks or even an on-prem application, the query, the application asks Ranger, does this user have the access to do what they're asking to do on this data? If the answer is yes, and it's very fast because these are plugins. If the answer is yes, they get access. If no, then they get an error message. And we can also do masking and show the data. If someone has access to many columns, but not all columns of, say, a glue table, we can mask out the ones that they don't have access to and still give them what data they are allowed to see. Recently, we've really needed ACID compliance. So traditionally, big data lakes are write once, read many. We have things streaming in from set-top boxes in the cable world. Those aren't transactional. That's not transactional data. That's what we're used to. But now increasingly we are finding that we need to delete specific records from those from our Parquet files or whatever. We can do this in Spark, but it isn't terribly performant. It certainly can be done, but turns out Delta Lake does it much better. The deletes are much more performant, and you get to view snapshots of past data lake states, which is really pretty awesome. So we're really moving toward, I love this word, a lake house, being able to do write once, read many, and ACID all in one place. And that is largely thanks to Databricks. This is me. Please reach out to me in email if you wish, and I'll be happy to answer questions in the live session if you have any. So thank you very much for listening.